Okay, so for question 4, we're given that the acceleration for gravity is negative 32 feet per second. And we're given an initial velocity of this stone that we're throwing off the top of a building straight up into the air. We want to know when it hits the ground. And we know that it hits the ground 4 seconds later, so that after 4 seconds, its position is 0, it hits the ground. We're looking for the height of the building in feet. And so if the acceleration is negative 32, the velocity ought to be negative 32t plus some constant. Well, that constant is always the initial velocity, because when t equals 0, this goes away. So 40 equals 0 plus c, and our constant is 40. So we end up with v of t equals negative 32t plus 40 for our velocity function. And then from there, we're going to need a position function, because we want to know at what time it hits the ground. So our position function should just be the integral of that, which should be negative 16t squared plus 40t plus some other constant. And we, like we said, we know that it hits the ground 4 seconds later. So all we need to do is plug in 4 for t and 0 for our position to get that constant. And let's see, that should come out to be, what is that? That's negative 256. So 256 minus 160 ought to be 96. And so our function for the position is s of t equals negative 16t squared plus 40t plus 96. Well, the height of the building is the position of the rock at t equals 0, which is 96. So that should be the height of the building, 96 feet. Any questions on that?
No.
All right. Everybody's good with 4. All right. Next question, number 8. So number 8 says, what should the initial velocity be if you want a stone to reach a height of 100 feet when you throw it straight up in the air? So once again, we know that the acceleration is negative 32 feet per second. So we know that the velocity should be negative 32t plus the initial velocity. And that's what we're looking for, right, is the initial velocity. So we're going to write v equals negative 32t plus v naught. And when it gets to a height of 100, if that's the height we want it to reach, and it starts to fall, the velocity should end up being 0 there, because it's going to stop going up and start going down. So we know that this is one equation that we're going to have to use to deal with this. And we can integrate this to get s equals negative 16t squared plus v naught t plus some other constant. Well, that other constant is the height at which we might throw this thing from. And the height that we're going to throw this from will be 0, right? So we don't need to put that constant there. So we just have s equals negative 16t squared plus v naught t. And we want the height to be 100. So we've now got 100 equals negative 16t squared plus v naught t. And if we just solve this for v naught is 32t. Plug that in, you get 100 equals negative 16t squared plus 32t squared. That gives you 100 equals 16t squared, or t equals, what is that? 100 over 16 reduces to 25 over 4. And you take your square root, you get t equals 5/2. And so it will reach that height at t equals 5/2. We want to know the initial velocity required for that. So all we then need to do is figure out what v naught is when t is 5/2. So our 0 equals negative 32 times 5 halves plus V naught. What does that come out to be? 80? 80 feet per second. Good or no?
Good.
No other questions there on number 8? Next one, I think it's page to turn, is number 11. Number 11 says solutions of the differential equation y dy equals x dx are of the form, and then it gives us 5 different things to choose from. So we just need to integrate this. Y squared over 2 equals x squared over 2 plus a constant. And then if we solve that for y, we'll get y squared equals x squared plus 2c, or y equals positive or negative square root of x squared plus 2c. And looks like that's choice. No. I guess we didn't even need to solve it for y, did we? So looks like that's just, if you were to take, you could solve this as x squared. Let's see here. One of those, yeah, I mean, you could have x squared minus y squared equals negative 2c, where negative 2c is just some constant. So x squared minus y squared equals constant. So it looks like A works just fine. B, the x squared and the y squareds need to have opposite signs. Neither the x squared or the y squared are being multiplied by a constant. So C and D don't make any sense. And E is effectively the exact same thing as choice B, which we already eliminated. So didn't even actually need to solve for y. Could have just done that from y squared equals x squared plus 2c, rearranged it. Everybody good there with 11? Any questions on 11? All right, next one is 12. We want to find the domain of the particular solution to our differential equation that we just did. So I guess we'll keep this on the same page. So we want to find the domain of the solution to this. If the point passes through -2, 1. So we'll go back to y squared over 2 equals x squared over 2 plus a constant. And we're going to plug in -2 for x and 1 for y. So 1/2 equals 2 plus c. So our constant is -3/2. So we got y squared over 2 equals x squared over 2 minus 3/2. Or y equals positive or negative square root of x squared minus 3. And since we plugged in a negative x but got a positive y, we're going to choose the positive square root there because we need to get a positive 1 out, not a negative 1. So we're looking at y equals the square root of x squared minus 3. And that tells us that x squared minus 3 has to be greater than or equal to 0, which tells us that x squared is greater than or equal to 3, or x is greater than or equal to the square root of 3, or x is less than or equal to the negative square root of 3. And since our x value is -2, we want x is less than or equal to negative root 3, which they didn't solve for the actual. They should have or equal to. I don't know why they don't have or equal to on there. That should be or equal to. But they came up with C as the answer choice for that, right? Yeah. Everybody.
So for differential equation questions, should we always consider the domain? So it would be wrong to put the absolute value, because the absolute value could technically work if it wasn't a differential equation question, right?
You can only choose the continuous piece that includes the initial condition. And so the initial condition is x equals -2. And so you can't do the absolute value because that includes two different intervals. That makes sense. Like absolute value of x is less than or equal to √3 includes x is less than or equal to √3 and x is greater or equal to -√3, which is two separate intervals. But when you find the interval of validity, it can only be one, always.
Okay, that makes sense. Thank you.
All right. Let's see here. Next question is 16. Um, 16 says the general solution to x dy equals y dx. So we'll just separate the variables and solve. Dy over y equals dx over x. Integrating both sides, natural log absolute value y equals natural log absolute value of x plus a constant. And if we were to solve this for y to try and figure out what these look like, we've got the absolute value of y is equal to the absolute value of x times e to the c, so some constant times the absolute value of x. And this is effectively just a bunch of different lines, like y equals x, right, with different slopes. Well, y equals x, or y equals 2x, or y equals a half x, or negative 0.3x. Those are all just lines that go through the origin. So it looks like 16 should be choice E. They're just lines that go through the origin. That makes sense for 16. Any questions on that? All right. Next one is 34. So 34 says which function is a possible solution for the slope field that is given to us. And so hopefully you're looking at the slope field there. But it sort of looks like no matter where you're sketching your solution curve, you've got something that looks, it's going to either look like this up above or like this down below. And so if you just think about each of those other functions, 1 minus 1 over x, well, 1 over x just looks like this. But if I've got, it's got two different pieces, so the opposite of it would look like this. And that's not what we've got on either side. So it couldn't be 1 minus 1 over x. Let's see here. The only one, I mean, that one looks like it's got a, and these both are approaching a horizontal asymptote, it looks like, of y equals 1 based on the graph. And so that's another thing we can look at. We know that 1 minus 1 over x does have that horizontal asymptote, but the curves go the wrong way. 1 minus ln x and 1 plus ln x don't have a horizontal asymptote, neither does 1 plus tangent x. But 1 plus e to the x does have a horizontal asymptote of y equals 1. And so the only one that makes any sense for that would be D, since that one is one of two that have a horizontal asymptote of 1, but the curve should be going in the same sort of direction on it, whereas on 1 over x, they have to be going in opposite directions. Does that make sense or no?
Yeah.
All right. All right, next one is 40. Let's see here. 40 says the population of a city increases continuously at a rate proportional to the population of that time. So we want to remember that if something increases or decreases at a rate proportional to how much of that thing we have, that's our exponential growth or decay model. So we could say that the population is the initial population times e to the kt. That's our exponential growth model that comes from the separable differential equation. That would look like dp dt equals k times p. Right? The amount of p, or how p changes, is proportional to the amount of p that we have. dp dt equals k times p. So p equals p naught e to the kt. We know that the population doubles after 50 years. So our final amount should be double the initial amount because it's doubling, equals the initial amount e to the k times, what did it say, 50 years? So we can use that, canceling out the p naughts to get natural log 2 equals 50k, or k equals natural log 2 over 50. And we want to know what the ratio of the population to the initial population is after 75 years. And so we would say final population equals initial population e to the natural log of 2 over 50 times 75. And we would just then go in and simplify this out to figure out what the relationship between p and p naught was. So first off, 75 over 50 is just 3/2. So this becomes p equals p naught e to the 3/2 ln 2, which is ln 2 to the 3/2. And then e to the ln of something is just that thing. So we end up with p equals p naught times 2 to the 3/2. And so it looks like then that ratio what is that simplify down to become? Looks like that comes out to be d, right? 2 to the 3/2 is just 2 root 2. So p equals 2 root 2 p naught. So it's 2 root 2 more than p naught is. Good or no?
Good.
All right. Let's see. Next question, 41. The same concept here. If a substance decomposes at a rate proportional to the amount of the substance present, and gives us a rate at which it's decreasing. So we'll just say S equals S naught e to the decreasing this time, so negative KT. And we know that it decreases from 40 to 10 in 2 hours. And it just asks us to find this value of K, this constant of proportionality. So this is 1/4 equals e to the negative 2k. Natural log of 1/4 equals negative 2k. Natural log of 1/4 is natural log of 1 minus natural log of, they left it in terms of natural log of 1/4. So No, they didn't. All right, this is natural log of 1 minus natural log of 4 equals negative 2k. Natural log of 1 is 0. The negatives cancel. So you end up with 1/2 the natural log of 4 is k, or k equals natural log of 4 to the 1/2, which is natural log of 2. And they have the negative out in front of it, but that's fine. Negative because it's decreasing. Good or no on 41?
Good.
All right, next one is 44. Okay, it's going to be similar. Oh, no, it's not similar at all. Oh, okay, so 44, there's, I believe, an issue with this one. I was doing this one during last period. It gives us a slope field for f prime of x, which is e to the negative x squared. It asks us what's the limit as x approaches infinity of f prime of x. Well, I mean, the limit is x approaches infinity of e to the negative x squared is just 0. So it doesn't make any sense that 0 is not an answer choice. I mean, 0 should be the answer to that question. And I was between classes, I went to go look and see what it says in their like descriptions, and it says as it's going through, they want what it does in the like the description of how to do the problem is it finds the limit as x approaches infinity of f of x, not the limit as x approaches infinity of f prime of x. So 45 is they've made a typo. That should say the question they wanted to ask is what is the limit as x approaches infinity of capital F of x, not capital F prime of x. So that changes that significantly. So the answer to what is written there is 0, right? Because they give you the function, just find the limit, and it's 0. But the way that they were expecting you to do that, if you were supposed to find the limit as x approached infinity of capital F of x, not F prime of x, was they would have said that this, that capital F of x should be the integral from 0 to x of f prime of t dt, which would be the integral from 0 to x of e to the negative t squared dt. And so they would just want you to see what happens as x goes towards infinity of this. So effectively, they'd say, well, just evaluate this integral at a very large value for x and see what it gets very close to. And so I'll do that real quickly here, just on Desmos to show that it comes out to be a, which is what they wanted the answer to be. But so the integral from 0 to, I don't know, we'll put in 10,000. It's a fairly big number of e to the negative x squared dx. And you can see it comes out to be 0.886 226925453 or whatever, which is very close to choice A, which is what they said the answer was. But they meant to write the limit as x approaches infinity of f of x, not f prime of x. So hopefully that clears that one up a little bit there for 55. Good or no? Okay. Oh, I was supposed to be doing 44 though, wasn't I? Oops. Well, that was 45 I was just talking about, which was the next one somebody had asked for. So we'll go back to do 44 now. So 44 says at any point of intersection of a solution curve to the differential equation y prime equals x plus y and x plus y equals 0, the function y at that point, and then they give us a bunch of options here. Is it equal to 0? Is it a local max, a local min, a point of inflection, a discontinuity, etc. So the first thing we'll do is we'll say if these two things intersect, let's take some piece of them that's the same and set those things equal to each other. All right. Well, if they intersect, that means that x plus y equals x plus y, which means that y prime equals 0, which means that we have a critical value, which means we potentially have a local max or a local min. But in order to figure out if we actually have a local max or a local min, or which one it is, we need to find a second derivative, or we need to make a sign chart. The sign chart's going to be really difficult because we don't have any values to plug in. We don't know for what values of x and y this is true. But we can use the second derivative test, which says at a critical value where y prime equals 0, not where y prime is undefined, but where y prime is 0, we'll say y prime of c equals 0. Then y double prime of c, if it's positive, then we have a min. And if y double prime at that c value is negative, we have a max. Okay? Because this is concave down and this is concave up. I said those backwards. This is concave up and this is concave down. So concave up means we have a min, concave down means we have a max. So now we'll find our second derivative. Our second derivative ought to be, well, the derivative of x is 1 and the derivative of y is y prime, which is just x plus y. Right? And well, we know that x plus y is equal to 0. So y double prime is equal to 1, which tells us this is concave up. And since it's concave up, it should be a min. That makes sense?
Yeah. I had a question for slope fields. What is the equation below that?
But I'm not sure what you mean. What is the equation?
Oh, like it says -2, 2 times.
That's just the window that they graph that on. So the x values are -2 to 2. The y values are -2 to 2.
Oh, okay.
Yeah. Everybody good there with 44 and 45?
Wait, for 45, you just put a really big number for the top limit of the integral, right?
Yep.
Okay. Because it like gave me a wrong number. It's probably just I typed something in wrong.
Could be, yeah. All right, we're going to go back to the beginning now to number 6. All right. Number 6 says we got a car accelerating from 0 to 60 miles an hour in 10 seconds. We want to know what distance it travels during those 10 seconds, assuming that the acceleration is constant. And they've given us a note that 60 miles an hour is the same as 88 feet per second. So really effectively, this thing is going from 0 feet per second to 88 feet per second in 10 seconds, which tells us that if the acceleration is constant, that must mean that our acceleration is 8.8 feet per second squared, since we've done that over the course of 10 seconds. And from there, we should be able to integrate to get v equals 8.8 t plus, once again, my initial velocity. Well, what's my initial velocity? It's going from 0 to 60 miles an hour. It's going to be 0. So we've got v equals just 8.8 t. And then we'll integrate that again to get s equals 4.4 t squared with an initial position of 0. So I don't need to bother with the constant again. And then we want to know what distance to travel in those 10 seconds. So that should be 4.4 times 10 squared, which ought to just be 440 feet. Good or no? All right. Next one should be number 19. Maybe my pen will work. There we go. Says the curve that passes through 1, 1 and has a slope of 3y over x. All right, so if it has a slope of 3y over x, that means that dy dx equals 3y over x. Or it means that dy over 3y equals dx over x. And if we were to go and integrate both sides of that, we might want to put the 3 over here. I don't know if we wanted to. We end up with natural log absolute value of y equals 3 natural log absolute value of x plus our constant. And if x is 1, y is 1, that would be natural log 1 equals 3 natural log 1 plus c, where c is 0. So we'd have natural log absolute value y equals 3 natural log absolute value of x. Or we'd have, and we can, since we know that we have a discontinuity at x equals 0, and our values here are positive, that x and y are both always going to just be positive. So really this is natural log of y equals natural log of x to the third power. And if we raise this as powers of e, if we exponentiate it, we end up with y equals x cubed, which was what, choice C, I think? Good or no? All right, next one is 24. 24 gives us what looks like a tangent curve. Right? Bunch of tangent curves in there. Saying that these are the solutions to some differential equation. We're looking for the actual differential equation. So if the solution to the differential equation is y equals tangent x, then we need to figure out what function has this as its antiderivative. And in order to figure out what function has this as its antiderivative, we need to sort of rearrange this a bit. Because if we look at these, y prime would be secant squared x, and clearly looking at choice A, y prime is tangent x. That's not true, because y is tangent x, y prime is secant squared. Choice B says y prime is cotangent, and cotangent is not the same as secant squared. 1 plus x squared is also not the same as secant squared. Neither is 1 over 1 plus x squared. Neither is 1 plus y squared. It wouldn't appear. So we got to be a little creative with this one. Rewrite this as x equals the inverse tangent of y, which would tell us that dx dy is equal to 1 over 1 plus y squared. And then we could take the reciprocal of both sides to get dy dx equals 1 plus y squared, which is choice E. I would be very surprised if they had you do something like that on the AP test. In fact, most of the questions in this differential equation ones are unlikely to appear in the multiple choices. Less likely to see multiple choice differential equations than in the free response like the ones we've been doing. No, there'll be 1 or 2 probably, but I would say most of these are more difficult than what you'll see on the AP test for differential equations.
Couldn't you use the identity? Like,
Definitely could, yeah. So
uh,
y prime equals secant squared x, you're saying? Right?
yeah.
Yeah, we could definitely do that. So this is y prime equals 1 over cosine squared x, which, well, actually, we'll just do this. 1 plus tangent squared x, and tangent x was y. And so you can just put that in 1 plus y squared. So that works too. Yep. Most definitely. Any other questions there on 24? All right. Next up is 35. 35 is again just asking us which differential equation has the slope field shown. So we just kind of got to think about these here. You can just plug in some values if you want to. That's probably the easiest way to go about this one. So, for example, if you plug in, let's see, well, that doesn't say if you plug in the origin, I thought that might eliminate an answer choice or two, but it doesn't. But we'll note that as the x values get very large and the y values get very large, it gets very, very large, which is certainly going to happen with A and with D, not necessarily going to happen with C because of the minus 2y in there. And we would note that 2y plus 1 and x plus 1, as we move to the right, they get steeper. And as we move up, they get steeper. So both x and y affect this. So it couldn't be B or E because neither of those have both x and y in them, and both the x and the y components. There's no, the slope fields aren't the same in vertical columns, or they aren't the same in horizontal rows. They change slightly as you go through. And so couldn't be B or E. The only reasonable choices then are A and D. And so probably the best way then is to just figure out somewhere, let's see, are there any places on there where we have a slope of 0? Looks like at 1, -1. So if we plug in 1, -1, that should give us a slope of 0. And A does not, but D does. So it looks like it should be D. There's not a lot to sort of write for that one. So hopefully just me talking through it makes sense. Does that make sense to everybody or no? Anybody have any questions on 35 after us talking through it there? All right. Let's see. Next one is 40. We did that one. Then 41. We did that one. Okay, 42. All right, 42. Let's see here. It says g prime of x squared equals g of x. For all real x, it says g of 0 is 0. It says g of 4 is 4. And we want g of 1. All right, so this one is a little bit, I would say a little bit annoying. Again, what I'm going to do is I'm going to say that g prime of x equals the positive or negative square root of g of x. And then I'm just going to say, let's let, just to get some like easier looking variables in here, let's let y equal g of x. So then I've really got the derivative of g, which is the derivative of y, which is dy dx equals positive or negative square root of y. And from there, I should be able to decide whether or not I have a positive or a negative here. And whenever I plug in a number, I get out a positive number. And so I should be looking solely at the positive square roots here. And if I've got dy dx is equal to the positive square root of y, we should be able to separate the variables on this. Dy over root y equals dx, and then integrate, giving us 2 root y equals x plus our constant. And we can plug in 0, 0 to see that that constant is 0. And so 2 root y, which is root g of x, equals x, or g of x equals x over 2 squared, so x squared over 4. And so g of 1 ought to be 1/4, which was what, choice A? That one's a little, I wouldn't expect anything that difficult on the AP test either. Good or no? All right. Let's see here. What was that? That was 42. 44. I've already done 44. Okay, so 50. 50 is similar to the ones we were doing a little bit ago. We've got a concentration of a medicine injected into a bloodstream. It drops at a rate proportional to the existing amount. So the amount of it should be the initial amount, e to the negative kt. That should just be that formula there. And let's see, it says the factor of proportionality is 30% per hour. So that means that after 1 hour, we should have 30% of what we started with. So that would be 0.3 of m naught is what's left if we start at m naught. Right, that's, yeah, the factor of proportionality, yeah. No, that's not what it's saying. Sorry, it's, let's go back to the beginning. It's saying the factor of proportionality, that's the constant of proportionality. So this is saying that dm dt is equal to 0.3 of m. So that's the differential equation is what they've given us. And so since it's decreasing, it's a negative 0.3 of m. And so what we need to do is we need to solve this differential equation to actually figure out what that constant looks like within the equation. So we're going to say dm over m equals negative 0.3 dt. Natural log absolute value of m equals negative 0.3 t plus our constant. And we know that this constant value is our initial amount, so we'll just say initial amount, because at t equals 0, the amount that we have is our initial. And so, sorry, that constant at 0 is natural log of the initial amount. So this is natural log of m naught. And so then we will, yeah, it's going to give us the same thing. We should have just left it. I don't know what I was doing there. This is m equals e to the 0.3t times m naught, which is what I had originally written there. Perfect. Okay, so that's our separable differential equation. That's our value for m. And what did we want to know about it? We wanted to know when the concentration will be 1/10 of what it started at. So we want to know when is m equal to 0.1 of m naught. So we'll say 0.1 m naught equals m naught e to the negative 0.3t. The m naughts will cancel. Take your natural log on both sides and divide. And what do you get for t? This is the calculator question, so I don't know. What is natural log of 1/10 divided by negative 3/10? Yeah, you didn't, yeah. Kyle, you didn't need to do the differential equation. I don't know. I started to set it up without doing it. I mean, and then I did it, and it, it comes out to be the same thing. It's always y equals y naught e to the kt, where k is that constant, and negative is decreasing. Anybody know what that value came out to be? I don't happen to have it.
About 7 2/3.
7 2/3 sounds good. All right, next one. 55. Okay, 55, you can't really do without having done 54. So let's real quickly look at 54. 54 says Newton's law of cooling, blah, blah, blah. The temperature of an object decreases at a rate proportional to the difference between the temperature and that of the surrounding air. So we've got a corpse, oh boy, fun, at a temperature of 32 degrees Celsius, arriving at the mortuary where the temperature is 10 degrees. So our differential equation should be the change in the temperature with respect to time. And since we're decreasing, it should be negative, and then k times the difference. It says the proportional to the difference between the temperature minus the surrounding temperature. So for 54, we should have got, looks like choice A for that one. And then so for 55, we've got to actually go and solve this differential equation. So we've got dt over capital T minus 10 equals negative k d little t. We integrate both sides to get natural log absolute value of t minus 10 equals negative kt plus some constant. And then we know that at time t equals 0, the corpse is at 32 degrees. So that tells us that our constant is natural log of 32 minus 10. So natural log of 22. So now we've got natural log absolute value t minus 10 is negative kt plus ln 22. When we exponentiate, we get t minus 10 equals 22 e to the negative kt. And then it tells us, what did it tell us? That the corpse took 1 hour to get to 27 degrees, I think. So we'll say that 27 minus 10 equals 22 e to the negative k times 1 hour. or 17/20 seconds equals e to the negative k. And if we want to find the value of k, which is what it's asking us to find, effectively, we take the natural log of both sides of this and get natural log of 17/20 seconds equals negative k, or k is negative ln 17/22, which is, what does that come out to be approximately? Let's see, that's got to be, what does that come out to be?
0.258.
0.258. So that's 0.258. And so we just plug that back in to our t minus 10 equals 22 e to the negative 0.258 t. And that should be our answer. Or it looks like they added the 10 over to get choice C. But other than that, that's what you should get. Everybody good there with 54 and 55? All right. Let's see. Number 4 we did earlier, so we won't go do that again. Next one is number 9. Number 9 says we've got the velocity of a car, which is v of t. It's traveling in a straight line. The difference in the odometer readings between t equals a and t equals b. So it's traveling in a straight line, so it could be going this way or backwards. It could be going back and forth. So we don't know if it's positive, or if its velocity is always positive. It might have a positive or a negative velocity. And to find the total distance traveled is always the integral from a to b of the speed. Remembering that speed is always absolute value of velocity. So this should be the integral from a to b of the absolute value of velocity dt for number 9, which is choice A. Good or no? All right, 39 is the next one. Let's see here. Okay, 39 is very similar to what we were talking about earlier with the exponential growth and decay. Radium decomposes at a rate proportional to the amount present, and the amount that is left after t years, with c being a negative constant of proportionality. I mean, that's just y equals y naught, or r equals r naught, e to the, and they said the constant is c, so to the ct. That's all that one is. Just that same formula we've been using today. Everybody good there with that now? All right, the next one is 40. We've done that. Then 41, we've done that. 55, we've done. 16, we've done. Brings us up to 11. I think we did 11 already also, didn't we? Yep, we did 11. Let's see. 12 is next. We did 12. Next one I got here is 14. All right, 14, we got dy dx equals e to the y. Y equals 0 when x equals 1. So first thing we got to do is solve the differential equation. So this is dy over e to the y equals just dx. dy over e to the y is e to the negative y dy. Now when we integrate, the integral of e to the negative y is negative e to the negative y equals x plus a constant. So 1 plus c equals negative e to the 0. So that's negative 1 equals 1 plus c, where c is negative 2. And if c is negative 2, then we should just be able to go back in and say negative e to the negative y equals x minus 2. E to the negative y equals 2 minus x. And then we'll take the natural log of that. So we got, once we're out of room there, we'll take natural log of both sides. So we got natural log of 2 minus x equals negative y. And then y equals the opposite of the natural log of 2 minus x. That's fun. That's not an answer choice. Did they just leave it as something else? Oh, they had e to the negative. No. Now they had e to the negative y equals 2 minus x. We didn't need to finish solving past that, apparently. That was all unnecessary because this was one of the answer choices. Everybody good there with that? 14 should be C. All right, let's see. $17. Have we done 17 yet? The general solution of dy dx equals y is a family of. So we just need to separate the variables. Dy over y equals dx. Natural log absolute value of y equals x plus some constant. Raise this to a power. E absolute value of y equals e to the x plus c, or if you want a constant times e to the x, those are clearly exponential curves. Any questions there on 17? All right, next one after 17 is 19. We already did 19. After 19, we've got 21. 21 says dy dx equals k over x, where k is a constant, and they give us y equals 2. Y equals 2 when x equals 1. They give us y equals 4 when x equals e. And they want us to figure out when x equals 2, what does y equal? So first thing we'll do is we will separate the variables on this. So it's already, actually we don't even really need to separate the variables there. We should just be able to integrate straight away since there's no y's in this. It's just k over x. So this should just be y equals k times the natural log of the absolute value of x plus some constant. And then in order to find out what those different constants are, we need to plug in our different values here. So if I plug in x equals 1, that ought to give me y equals 2, and then k ln 1 plus our constant tells us that c is equal to 2 since k ln 1 is 0. So c is 2. So now we've got y equals k natural log absolute value x plus 2. And we know that x, when x is e, y is 4. So we can say 4 equals k natural log e plus 2. Natural log of e is 1. So k plus 2 is 4. K must be 2. And so our solution should be y equals 2 ln absolute value x plus 2. And when x is 2, y ought to be 2 ln 2 plus 2, which was choice. Looks like, I guess that's choice E, right? This is the same as y equals ln of 2 squared, so ln 4 plus 2. Any questions there on 21? All right, next one is 24, but we've done that. 40 we've done, 41 we've done, 42 we've done, 44 we've done, 45 we did, 50 and 55 we've already done. Okay, next set from somebody. Back to the beginning again, number 2. All right, so number 2 gives us an acceleration equation. A of t is 20t cubed minus 6t. We're given position at -1 is 2, position at 1 is 4. Find v of t. So we're going to integrate a of t to get a basic function for v of t, which is going to be 5t to the 4th minus 3t to the 2nd plus some constant. And then since we're given initial values for position, we're going to integrate this again to get s of t is equal to t to the 5th minus t to the 3rd plus constant 1 times t plus some other constant. And we should be able to plug in both these values to get 2 different equations with both these unknowns c1 and c2, so we can solve a system of equations. So if I plug in -1, I should get 2. So -1 plus 1 minus c1 plus c2. So effectively 2 equals -c1 plus c2. And if I plug in 1, I should get 4 equals 1 minus 1 plus c1 plus c2, which effectively gives me 4 equals c1 plus c2. We want to find the velocity function, so we really need to figure out what c1 is. Let's just subtract these. -2 equals -2 c sub 1. C sub 1 equals 1. So v of t ought to be 5t to the 4th minus 3t to the 2nd plus 1. Good on that one or no? All right.
Thank you.
Next one was number 3. Number 3 says given a of t, given all the stuff from question 2, find s of 0. Okay, so if we need to find s of 0, we're going to need to find constant 2 also. So if constant 1 is 1, looks like constant 2 should then be 3, just based on this equation right here. So we can go in and say that s of t is t to the 5th minus t to the 3rd, what was it, plus t plus 3, right? And if we want s of 0, well, that's just 3. Pretty easy if you got number 2 done. Everybody good there with 3? Okay, let's see. Next one is 8. I think we did 8. Yeah, we did 8. Then the next one is 10. I feel like I'm doing like every single problem on this whole packet, almost. All right, number 10. An object is moving up and down along the y-axis with the velocity v of t and a position's derivative that is v of t. Says then it is false that the integral from a to b of v of t. So what does this not give us? So the integral of v of t from a to b. So first option it gives is s of b minus s of a. Well, that's the definition of a definite integral. If the integral of v is s, which is what it says, then this must be true. So good. B, the net distance traveled by the object between t equals a and t equals b. Yeah, okay, so the net distance, that's a poor term, but a net distance just means the displacement. So that is definitely, that's exactly what displacement is. It's the integral of the velocity. The total change in position, that's the same thing as displacement, so that's also true. The shift in the object's position, that's also displacement, so that's true. And E says the total distance covered. Total distance would be the integral of speed, right? E would be the integral of the speed, or the integral of the absolute value of the velocity. So choice E for number 10. Everybody good there? Okay. All right, 16 was the next one, but I'm pretty sure we did 16, yeah. And then 18. All right, 18, we've got a function that satisfies f of x, f prime of x equals x with f of 0 equal to 1. So we're looking for a function that satisfies this. So here's what I'm going to do. I'm going to call f of x y, and I'm going to call f prime of x dy dx, and call that equal to x, and just separate the variables. So I got y dy equals x dx, y squared over 2 equals x squared over 2, plus a constant. When x is 0, y is 1. We get a constant of a half. Y squared over 2 equals x squared over 2 plus a half. Multiplied by the 2, we got y squared equals x squared plus 1. And y equals either positive or negative. It's going to be positive since we get a y value of 1. The square root of x squared plus 1 there for 18. Any questions there on 18? Everybody good there? It's like people are leaving, like class was supposed to be over a minute ago. Any other questions on 18? All right, let's see here. 24 we've done. Have we done all the rest of these? No, we haven't done 29. All right, I guess. Let's see, how many of these? Let me see. The only one I think we haven't done. All right, we have one question to go. 29 is the last one that somebody has asked for that I haven't already done. So we'll do 29 and then we'll be done. So hopefully you all can stay another minute or two here. Oh, cool. All right, it says, which slope field is for the differential equation y prime equals e to the negative x squared? So you should be looking at those slope fields on the previous page. It said that they were for questions 25 to 30. And if we're looking at e to the negative x squared, as we go towards, as we plug in values that get larger in terms of x, the values should all be getting closer and closer to 0. And so if you look at both 1, 2, 3, and 4, as the x values get very, very large, or even as they get larger at all, they're definitely not approaching a value of 0. Only 5, as the x values get larger, are approaching a value of 0. And another thing to note is that one, the y values don't matter for 5. So some of the other ones, the y values also don't matter, but the y values don't matter for 5, and as the x values get larger, it should be approaching 0, which is what all those do. Does that make sense for number 29? There's nothing really to write for it, but I know that was your question. Yeah, does that make sense?
Yeah, it makes sense. Thank you.
Yep. All right, I think that's it. We made it through with only a couple minutes going over. Sorry, we went over. You'll all survive.